simple example. We've shown that if you have a tadpole and you put an eye on its tail instead of in its head, those animals can still see. The eye can connect to the spinal cord, the brain can recognize information coming from its tail somehow, and those animals can still see. Similarly, if you make a tadpole where the craniofacial organs are scrambled and the mouth is sort of off to the side, during the steps towards metamorphosis, all of this stuff will sort of rearrange and you'll get a pretty normal face out of it. Those now, what are those? Those are competencies of the individual organs. It means that if you induce an eye on the tail or a mouth off to the wrong place, they have the competency to still get their job done. The cells will do what they need to do to get as close to normal as possible. This has massive implications for evolution, because if you didn't have this, if you had an organism that was basically Lego, right, where every piece just goes exactly wherever the genome to put it, that's where it goes. Okay, and I'm not sure there are any organisms like this. Maybe C. elegans, maybe, I'm not sure. But if you had organisms like this, then anytime you had a mutation, let's say that you had a mutation, and like all mutations, it does multiple things. Let's say that it moves the mouth off to the side, but also does something useful somewhere else. Well, evolution would never get to see the useful part because that animal would starve and the fitness is 0. And as you would expect, most mutations would be negative. They would be deleterious. And so the search space, right, that evolution would have to search would be really rugged, because you would have to wait until you found a different mutation that did the good thing but not move them out. That might be very hard. It might be impossible. However, in contrast, imagine that you had an animal which is much more realistic, where the parts had some competencies, and so now this mutation shifts the mouth or the eye, and it also does something else. Well, now those parts will get back to where they need to go. They will be functional. So now evolution gets to explore the other consequences of that mutation. So by having the parts be competent, it greatly smooths and alters the landscape of that evolution has to search, because now all those potentially negative mutations are neutral, because the competencies of the parts can sort of make up for a lot of that. So that has a couple of interesting implications. The obvious one that's obvious and one that's really not obvious. The obvious one is that it makes things much more evolvable. And so it means that you're now searching, instead of searching a really difficult space of micro positioning of all this stuff, you're searching some kind of a reward space where it's really behavior shaping. Right? Your material is not passive; it's an agential material. Your cells already have capabilities and preferences and signal processing and so on. So what you're searching is the signals that will get them to do specific things. The not obvious thing is that by having competent parts, you are hiding a lot of information about the genome from selection. Because if selection gets hold of a pretty good individual, you can't tell whether that's a good individual because the genome was amazing, or because the genome is actually not very good, but all the parts sort of made up for it, right? So maybe the genome had all kinds of problems with where the eye is supposed to go in the mouth, but by the time selection acts, everything's where it needs to be. That sets up a positive feedback loop that becomes an intelligence ratchet, because the more competency you have, the less evolution is able to select for better genomes. And the only work that can happen at that point is to select for more competency, because you can't select for better hardware because you don't see the hardware. You don't see the genetics that specify the hardware. But what you might be able to do in evolution is to improve the competency. And so therefore, there's this kind of runaway effect where I think that's, and if you want to talk more about this, I have an example with planaria that I can talk about.